Yeah, hi students, very good evening everyone. Welcome to the next video on the Om Institute YouTube channel and the series Learn Concept through PYQ. Yes, so we have been discussing some concepts taken up from linear algebra. Of course, first you have targeted linear algebra and in the previous videos we have covered the rank of the matrix, linear system of equations, non-homogeneous and homogeneous both, and a very important eigenvalue and eigenvectors. The today's class is more or less a continuation of this particular video. It is more or less the continuation of eigenvalue and eigenvector, okay, which is in the form of Cayley Hamilton theorem. Yes, guys, because the Cayley Hamilton theorem requires the use of characteristic equation, the same characteristic equation which we have discussed and developed using the eigenvalues and eigenvectors discussion. Okay, but this topic independently is again very important. Okay, whatever your branch may be, but frequently questions can be expected from Cayley Hamilton theorem, and it is again, I'm repeating, based on characteristic equation. Okay, yeah, so very good evening everyone. Good evening, everyone. Everybody keep joining. Yes, and quickly update all your friends that the session is now live. Okay. Update all your friends that the session is now live so that everybody can keep joining. Yes, just a moment. Okay, hope audio video, you also let me know, just confirming from my side. All right. Okay, yeah, come on. Yeah, let's get moving ahead. Good evening, Ganesh. Okay. Yeah, so finally, let's get started and talk about the Cayley Hamilton theorem. As I know, we are learning concepts through PYQ. Okay, so let's get started with the first PYQ of the day, and this is a very recent one, GATE 2025. Okay, 1 mark question. Okay, if A, then which of the following? If A is the given matrix, which of the following is A power 8? Now dear, what is important here is, question will never speak that it is a Cayley Hamilton based question where you are going to apply. Okay, whenever you look into any higher power of A, see, this is a higher power of A, whether it is A power 8 or A power 4 or even higher power, okay, you can think about Cayley Hamilton theorem. What is that Cayley Hamilton theorem? Okay, what is that Cayley Hamilton theorem? Okay, as I told you, which is, mostly used for calculation of higher powers of A, or towards the negative powers of A, I mean the inverse powers of A. The inverse of A. It simply says that every square matrix satisfies its own characteristic equation. And what is the characteristic equation? Okay, what is the characteristic equation? Okay, that we have discussed with the eigenvalues and eigenvectors previous class. It is given by generally modulus of A minus lambda I equal to 0. Okay, but then I have also given you the simplified characteristic equation for 2 cross 2 and 3 cross 3 matrices. All that we will again use here and revise the things. Okay, so the previous question is on 2 cross 2. Okay, so every square matrix will satisfy the characteristic equation. What is the characteristic equation here? Okay, so since it's a 2 cross 2 matrix, okay, what is the 2 cross 2 characteristic equation? Generally, as we know, modulus of A minus lambda I, but for 2 cross 2, we simplify and write down the direct characteristic equation as lambda square minus trace lambda plus determinant equal to the 0. Correct? Plus determinant equal to 0. Keep solving, and if you get any answer, please do let me know. Okay, so now what is the trace of the matrix here? What is the trace of the matrix here? Okay, trace, sum of the diagonal numbers 1 minus 1 into lambda plus determinant minus 1 minus 4. Just cross multiplied. Okay, so what is this characteristic equation? What is this characteristic equation in front of you now? This 1 minus 1, the trace is 0. So only lambda square minus 5 equal to 0. Now you see what is Cayley Hamilton theorem. Every square matrix will satisfy its characteristic equation. Okay, so now if you have to apply Cayley Hamilton theorem, okay, the Cayley Hamilton theorem says that the matrix also will satisfy this equation. So what is the matrix? Is A. Okay, so the equation will look like, rather than lambda, you'll put A. But only thing is, with matrix, what can be added or subtracted? Important point, you should not write 5. With matrix, what can be added or subtracted is a matrix only. So we'll consider that as 5i, identity matrix or unity matrix you can use. So A square minus 5i equal to 0. So this is a simple one only. What is A square? It is 5i. Okay, question is talking about A power 8. Okay, so what is there? A power 8 you can write as a square power 4, right now? Okay, so that means it is 5i whole power 4. Okay, so this is equal to, what is 5 power 4? 625, and I power 4 remains to be I is identity, any power will be I only. Okay, so answer is 625i. Now identity matrix, you know, diagonal elements are 1, 1, so 625i, 625, 0, 0, 625. That is which option matching here? Option number C, easy one, option number C, correct answer. This is the easy one only, right? 625, 0, 0, 625. Sometimes, as I will show you, the options are in the form of matrix A only, A power 4 or A power 8 in terms of A or identity. Okay, so if it is in terms of identity, answer is 625. They have given the option in the matrix form, so I have written the matrix. Okay, so now let's move and practice more questions. Okay, this is a small topic but actually important. Small but actually important. Correct? Yes, yes, yes. Okay. Any doubt, please message me. So yeah, look into it. GATE 2004 CS 1 mark question. Old question, but it's a 4x4 matrix. So I have taken out here characteristic equation. Modulus of A minus lambda equal to 0. Okay. And I have given you the short characteristic equation, the short form for characteristic equation. If it is a 2x2 matrix or 3x3 matrix, that much I have given. But this is 4x4. Okay, dear, this is 4x4. What will you do for this? This one is the 4x4. What will you do for this? Rather than forming characteristic equation, let's apply a small logic. For that reason, it's a simple question only. Okay, but for a different approach, I have taken this question. What is the type of the matrix? Okay, see here, everybody. What is the type of the matrix? Can anybody say the eigenvalues? We have discussed a point. Can anybody say and think about the eigenvalues? Okay, what is the point we have discussed? Whenever the matrix is a triangular matrix, upper or lower, anything. This is upper triangular matrix. So the eigenvalues are always the diagonal numbers, just equal to the diagonal numbers. 1 minus 1, I and minus y. Okay, so what I have started this question with the eigenvalue calculation. Okay, I have started with eigenvalues. And what are the eigenvalues? Eigenvalues are also known as roots of characteristic equation. So dear, what should be the characteristic equation here? Roots of characteristic equation. What should be the characteristic equation here? Okay, characteristic, if lambda equal to 1 is the root, so characteristic equation should have a factor lambda minus 1. Okay, then next is lambda plus 1. Next is lambda minus I. Next is lambda plus I. This is equal to 0. Lambda minus 1, lambda plus 1, lambda minus I, lambda plus I equal to 0. That means lambda minus 1, lambda plus 1 means lambda square minus 1. Next, lambda square minus I square. But what is I square is minus 1. So I will write it as lambda square plus 1. Okay. So finally, what is the characteristic equation? Again, a minus b, a plus b. So lambda power 4 minus 1 equal to 0. So hence, okay, this is a reverse way of getting the characteristic equation from the knowledge of the eigenvalue. Okay. So dear, what is the characteristic equation? Let me complete it here. Characteristic equation, lambda power 4 minus 1 equal to 0. Cayley Hamilton theorem. Okay, just satisfy the equation in terms of A. So A power 4. 1 means in matrix form you will write it as identity. So question is only asking A power 4. So the finish answer is finish. A power 4 is I. Option number A. A power 4 is just equal to I. Correct answer is A. That's it. Finish na? Correct answer is A. Lambda power 4. A power 4 is I. That's it. Okay, next. Yeah. Next question. GATE 2007 EE2 marks question. I'll come to some recent questions also. Okay. If A, again a 2 cross 2 matrix, satisfies what relation? Simple one only. So actually it's a common data question. Okay, I'll tell you it's a common data question. You know, till 2010 you had the common data questions as well. Not 2010. Till 2013. Yeah. You had common data questions and linked questions. Okay. So this was a common data question. Okay. Common data or linked, I don't remember. Probably this was common data. It should not be linked question because both are independent. Okay. This is the first question. If A is the matrix given, okay, then this is the first question. Okay. This is the first question. A satisfies what relation? A satisfies what relation? Okay, so the options are in terms of some expression of a polynomial a square or a plus I, a plus 2i. Okay, so that can be obtained by characteristic equation, Cayley Hamilton theorem. Okay, so what is that characteristic equation first of all? Again, I will first start with characteristic equation. 2 cross 2 matrix. Directly write down lambda square minus trace lambda plus determinant equal to 0. Correct? Okay, so let me see any answer till now. No, easy one only. Again, same 2 cross 2 characteristic equation is actually very easy, na? 2 cross 2 characteristic equation is actually very easy, na? Okay, so what is the value of the trace? Minus 3 plus 0, sum of diagonal numbers, and determinant of the matrix 0 minus the plus 2 equal to 0. Okay, so you have lambda square minus plus 3 lambda plus 2 equal to 0. So dear, now if you apply the Cayley Hamilton theorem, okay, every square matrix will satisfy the characteristic equation to put lambda equal to a square plus 3a plus 2i equal to 0. A square plus 3a, so not the option number B. Okay, not the option number B. Even A will not be satisfied. A is with the idea, if you multiply with, this is how inverse can be calculated. This is the idea of inverse. Multiply throughout by A inverse. So still what you will get, A plus 3i, A into A inverse will cancel, plus 3i plus 2a inverse equal to 0. So this minus will not match. Okay, so probably option number C. There is no link of e power here. Okay, yeah, because it is factorizable. Na? Okay, sum is 3, product is 2. Okay, so 1 plus 3 and 1 plus 2 and 1 into 2. Okay, that is A plus I, a plus 2i, 1i and 2i. Okay, this is the factorization. So option number C is matching up. Option number C. That rearrangement takes you towards option number C. As I told you, this is common data. Okay, for the same matrix, now you see, okay, the same matrix, the question number 2. Question number 2. What is a power 9? What is a power 9? So, what is the result obtained? So, we'll solve it in continuity. No. I think this is wrongly mentioned. Gate 2012. No, this is a linked question. Okay, this is swapped, I think. Sorry. This is gate 2007 only, dear. Gate 2007 EE. That continuity common data question. Okay, dear. That is continuity common data. Same question only. I think it has been swapped. And the next one will be this gate 2012 question, which was commonly asked in EC as well as EE as well as IN, and for 2 marks, which is a simple question. Okay, we'll come to this also, but yeah, before that, a power 9. Let's come up to this. Now, a power 9, sometimes recursively we have to use Cayley Hamilton. So what is the result here we got after Cayley Hamilton? What is the result we got after Cayley Hamilton? Let me check for any doubts. No, nothing. Okay. Yeah. So what is that, the result we got from Cayley Hamilton? We got a square plus 3a plus 2i equal to 0. So from here, at least which higher power you can obtain? A square minus 3a minus 2i. So we have to use this relation recursively. Sometimes it may be little calculative, because to come up to a power 9, I only have a square right now. So first let's create a power 4, because a power 4 is square. Okay, a square. Okay, so this will be now equal to minus 3a minus 2i whole square. Minus square is plus only, so call this as a plus b whole square. So a square 9a square plus b square. So that becomes 4i. I square is 1, I only, plus 2ab. So 2, 2, 4, 3, 12. So plus 12a. Correct, na? Yeah, plus 12a. Okay. Now again you have to substitute in terms of a, because options are in the form of a and identity. So again you have to replace a square by this relation. Okay, so this is equal to how much? 9 times minus 3a minus 2i plus 4i plus 12a. So solving it further, what is a power 4? 9 into minus 3, minus 27 plus 12, so minus 15. And 9 into minus 2, minus 18 plus 4, minus 18 plus 4, so minus 49. This is a power 4. Okay, now further next step is a power 8. Okay, which can be written as a power 4 whole square. Then one more step, we'll get a power 9. Okay, so little calculative, but okay, no problem. Okay, minus 15a minus 14i. Okay, but at least if you consider this as a 4-mark question to this one, okay, to this one, because what is there in this question? Nothing, na? This was just a 1-marker type question. They have put it as 2 marks. So total by the same matrix, it's like 4-mark question they asked. Okay, but now there is no common data or linked question pattern in GATE. Okay, so now when we are going to take the square of this, again minus square is cancelled. So 15 square 225, a square 14 square 196, I square is I, and plus 2ab. Okay, so plus 2ab will be, first let me do 15 into 14, 150, and 210 into 2, 420. 420a. Again dear, a square. Okay, again a square will be put at this one. Okay, minus 3a minus 2i. Okay, so let me keep solving. Okay, let me keep solving here. Where is that question gone? Yeah. A raised to the power 8. Okay, how much? 225. I am substituting a square, that is equal to minus 3a minus 2i. Okay, and then plus 196i plus 420a. Okay, keep looking, keep solving. I told you it is calculative. I told you little calculative. Okay, but no problem. Okay, minus 225 into 3. Okay, how much will be the answer? Let me just calculate and write down. Okay, plus 420 also will be there. So this is minus 6. Just a second. Plus how much? Plus of 420. Okay, so this step a power 8 answer is minus 255 to 55a. Minus 255a, and then 225 into minus 2. So this is 450, right? And plus 196. Okay, so this is minus 254i. One last step, a power 9. Now a power 9 will be a power 8 into a. Okay, so into a, when you multiply, you get minus 225a square minus 254a. Okay, minus 225a square again to be put as minus 3a minus 2i, and then minus 254a. Okay, so final answer should now come up, a power 9 as how much? Okay, so this is now 225 into 3 plus 225 into 3. Okay, so I'll write it as 675. Okay, and then minus 254. Minus of 254. Okay, minus of 254. No, I think some error happened somewhere. Was this not correct? Let me just recheck the calculations. I guess some error, because option, and that was okay. I missed that or what? This part is correct. Okay, just let me recheck this. 225 it is. Correct only. Then minus 3a minus 2i. $421, but as far as I see, there is no 421. Somewhere some calculation error has happened. Okay, let me recheck it. Anybody? Okay, I'll move to the comments. Anybody, any clue? No. Just some calculation check has to be done. This is correct. 9a square plus 4i plus 2ab. Okay, so 2 to 4, 3, 12. This is correct. Okay, then a square I have written as minus 3a minus 2i. This is also correct. Okay, minus 27 plus 12 minus 15i, and 9 minus 2 minus 18 plus 4 up to this is correct. Now taking the square, 225a square correct only. Okay, 15 square correct. Then 196i plus 2ab, so 15 into 14, 210, 420 correct. Okay, so 225a square again put as minus 3a minus 2i plus 196 and plus 420a. Okay, so where is the error happening? It is going fine only. This is finally minus 225a, 255a. Oh, sorry, 255. Yeah, that typing error, I guess. 255. Okay. 255, everything is correct only. I think here just I have written 255, and so that the end calculation changed. Okay, no problem. I will check it now again. Guys, you can also at least hint here how much it is. Okay, 511a, and then minus, this is also plus 255 into 2, 510i. Correct. 511, 511a plus 510i. Okay, that is the option number A. Okay, now option number A. Check your calculation also. Check your calculation. Let me for any discrepancy yet. But yeah, I think it is now correct. Okay, so see, till a power 9, it took us some time to go. But now if you see the next question, which was there in GATE 2012, EC, EE and IN, and this is an easy one for 2 marks again. Okay, because it is a 2 marks level question. Again, the characteristic equation. Okay, you will start with lambda square, again 2 cross 2 matrix only, minus trace into lambda plus determinant. Will the question only be on 2 cross 2? No, I will show you 3 cross 3 as well. Okay, but first let's complete this. So lambda square minus trace. What is the trace here? Minus 5 plus 0, and determinant here is 0 minus plus 6. Okay, so the characteristic equation here is lambda square plus 5 lambda plus 6 equal to 0. And if I apply the Cayley Hamilton theorem, okay, the lambda will be replaced by a, so a square plus 5a plus 6 identity equal to 0. Okay, so directly I get what is the value of a square? Minus 5a minus 6i. So this is just one step calculation, because they are only asking a cube. So a cube is a square into a. When you multiply a, you get 5a square minus 5a square minus 6a. A square again you put back. What is a square? Minus 5a minus 6i. And then further minus 6. So solving it, 5 5 25 minus 6, 19a plus 5 6 30i. 19a plus 30i. Finished. 19a plus 30i, finish. Option number is B. Option number B, 19a and 30i. 19a plus 30i, option number B is the very correct answer. Done, dear. Okay. GATE 2018 EC 2 marks, and now a 3 cross 3 matrix. A 3 cross 3 matrix. Okay, dear. A 3 cross 3 matrix. Now, dear, let's learn with respect to this. First of all, 3 cross 3 characteristic equation. Let's recall the 3 cross 3 characteristic equation. What was the 3 cross 3 characteristic equation? Okay, if you have not watched, I will request you to go through the eigenvalue, eigenvector previous video available on the YouTube. Okay, because that is actually very, very important. Linear algebra, most important area is eigenvalue, eigenvector only. 3 cross 3 shortcut characteristic equation, I have given you lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0. This is the shortcut characteristic equation I have given to you. Lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0. Correct? Okay, now what is beta 1? Just a quick recap. Beta 1 is the trace again. Okay. Trace, sum of diagonal elements. Sum of diagonal elements. Okay, so what is the trace here? Okay, 1 plus 2 plus minus 2, so which is 1 only. What is beta 2? Beta 2, first I will write down the definition. Beta 2 was defined as the sum of the minors of the diagonal elements. Sum of the minors of the diagonal elements. Okay, so beta 1 is sum of diagonal elements, beta 2 is sum of the minors. Like this is the diagonal element. What is the minor corresponding to it? Minus 4 minus 0. Directly writing the value. Minus 4. Next diagonal element. What is the next diagonal element? Here it is 2. Okay, deleting the row and column, I get the minor value. Minus 2 minus 0, so which is minus 2. Plus the third diagonal element. Okay, this is minus 2. Delete the row and column. You get 2 minus 0, which is 2. Okay, so total beta is minus 4. Total beta 2 is minus 4. And what is the beta 3 factor? The last one is simply the determinant of the matrix. Okay, so what is the determinant of the matrix? Okay, let me simply expand about the first row. Okay, 1 and minus 4 minus 0. Then this is 0. Last element minus 1. Okay, with minus 1, 0, 0 only. Okay, so the determinant is minus 4 actually. Determinant is minus 4. Now you see, okay, the question is asking determinant of B. Okay, and B is a matrix obtained by higher powers of A. Okay, so it's not, do not think this question as first you have to create A square and A cube by matrix multiplication. Okay, that will take you towards a very lengthy process. First you calculate A square, then A cube, then add and subtract these matrices, then you calculate determinant. No. Okay, Cayley Hamilton theorem, higher powers of A and higher powers of A. Okay, so Cayley Hamilton theorem. Okay, A and higher powers of A will take you towards Cayley Hamilton theorem. But for Cayley Hamilton theorem, I need characteristic equation. So let me write down the values of beta 1, beta 2, beta 3 in the equation. Okay. So what is the final characteristic equation? Lambda cube minus beta 1 lambda square. Beta 1 is 1, correct? Minus beta 1 lambda square, so that is 1. Okay, then plus beta 2 lambda. Beta 2 is minus 4, so minus 4 lambda minus beta 3. Okay, that is minus will become plus 4 equal to 0. Now substitute Cayley Hamilton theorem. That means replace the lambda by A. So you will have A cube minus A square minus 4A plus 4 identity. Remember, with matrix you have to write identity only, equal to 0. Now what is the given matrix B? See, what is the given matrix B? Something like this only. A cube minus A square minus 4A plus 5i. See, this is given, a cube minus a square minus 4a plus 5i. Okay, so this is how much? You can split this. A cube minus a square minus 4a plus 4i plus I. The 5i can be written as 4i plus I, because this much of the result as per Cayley Hamilton is 0. So what is the matrix B? Matrix B is simply identity. Okay, so what is the determinant of B? 1. Determinant of identity matrix is 1. Finished. The answer is 1. The answer to the question is 1. Any doubts, please let me know. Okay, dear. Let's conclude here. So this is the matrix. Next question, GATE 2022 EE2 marks question. Okay, consider the 3 cross 3 matrix. Again, there is a 3 cross 3 matrix, and there is a matrix which satisfies, this matrix satisfies the relation. What relation? It is the relation of inverse. A inverse. Okay, inverse of the matrix again can be written, inverse in terms of A or A square can again be written using Cayley Hamilton. Higher powers of A or inverse, Cayley Hamilton theorem can anytime be used. Okay, so there is the equation of inverse given as 6a inverse equal to a square plus 6a plus a square. 6a inverse is a square plus ca plus di. C and D are scalars and I is identity matrix. What is C and D? I mean, they are asking C plus D. So first we can find both C and D. Okay, let's find out the characteristic equation. So what is the beta 1? The first thing is, what is the beta 1? As I told you, trace. Okay, 1 plus 4 plus 1, 6. What is the beta 2? Sum of the minors of diagonal number. First diagonal number, minor is 4. Okay, and minus plus 2. This is the first minor. Then next, what is the next diagonal element? 4. Delete the row and column. So minor left is on cross multiplication 1 minus 0. And the last one, this is the third diagonal element. Okay, 4 minus 0. Okay, so what is the answer here? 6, 7, 4, 11. Okay, so the beta 2 is 11. Same beta 1, beta 2, beta 3 like last one, and beta 3 is the determinant. What is the determinant? Okay, only this 1 and 4 plus 2. Okay, so determinant is simply equal to the 6. Determinant is simply equal to 6. So now I will put this in the characteristic equation. Okay, what is there in the characteristic equation? What is there in the characteristic equation? Lambda cube minus beta 1 lambda square, that is 6 lambda square, plus beta 2 lambda, that is 11 lambda, minus beta 3, that is minus 6, equal to 0. Okay, Cayley Hamilton theorem. Replace lambda by a. So a cube, 6a square, 11a, 6 identity equal to 0. But the question is giving you inverse expression. Huh? What will you do? Any answer? No? Come on, quickly solve it. Okay. Right. Okay, yeah. So multiply both the sides by A inverse. Multiply both the sides by inverse. Okay, so what do you get? A inverse into A cube, that is A square, minus 6. A inverse into A square, 1A will get cancelled, 6A is left. Plus 11, A inverse into A, cancelled, identity left, minus 6. A inverse into I, A inverse, equal to 0. So yes, we correctly get the expression of 6A inverse now. 6A inverse is equal to A square minus 6A plus 11I. What is given to you? A square plus CA plus DI. A square plus CA plus DI. Okay, so this is C minus 6 and this is D 11. So what is C plus D? D is 11, C is minus 6, C plus D becomes 5. Even if they ask individual value, we know minus 6 and 11, so C plus D is 5. Okay, option number A. Correct, na? C plus D is equal to 5 minus 6 plus 11. Correct. Simple one. What is there in this question? 2 marks question. So very commonly 2 mark questions can be expected from Cayley Hamilton. The basis is characteristic equation, okay, which we have discussed with the eigenvalues discussion. With the eigenvalues and the eigenvector discussion. Correct, na? Okay. Okay. Yeah. So, yeah, important quick updates for all of you. Okay, regarding to the new offline batches. Yeah, so as I was mentioning, important details for you that yes, if you want to prepare for GATE 2026 in a competitive atmosphere in the offline manner, and that too live in front of the best ECEE faculty team, yes, you can join for the new offline batches. The new offline batch for EE starts 18th August. Okay, for EE it starts 18th of August, and for EC just 10th of August. Just started 10th of August. Just a second, what is the issue happening here? Yeah. Now looks okay. Yeah, so that is what, okay, the new batch for EE 18th August and EC, as I just mentioned, on 10th of August. Okay, the fee 65,999 is currently priced at 54,999 with some special discounts as mentioned. For any queries, you can contact 95156940553. Okay, and if in case you can't enroll for offline course, you can't travel to Hyderabad and stay here for offline, but still want the guidance from the same best ECEE faculty team, okay, you can also enroll to our online live course. Okay, the GATE 26 and 27, both the modules are available with 1 and 2 year respective validity. The fee is respectively also mentioned in front of you. And this month, the month of Independence, okay, the OM Institute brings to you a special offer on the occasion of Independence Day. Okay, flat 20% off, flat 20% discount on all the online courses of OM, that is live as well as recorded. Okay, you just have to use the code FREEDOM20 while purchasing any code, and this is valid, okay, till 20th of August. Okay, we have extended this till 20th of August. Okay, so take the benefit and enroll into our online courses, okay, with the flat 20% discount. All right, and if you want to prepare for the AE exams like the Telangana Transco Discoms or AP Transco Discoms, the new offline batch again at our Hyderabad center starts August 10th. Okay, starts August 10th. All right, so yeah, that's it for the video from my side, and as always, I'll share you the PDF of the video, in my Telegram group. I'll keep a small password protection on the PDF, and that is CHT, Cayley Hamilton Theorem. Okay, everything in capital. Okay, so you can get the PDF from my Telegram, but it will be asking for a password, and that is CHT. Okay, you know why I keep the password. I have that rules. Okay, so thank you everybody for joining. Okay, and yeah, do not forget to put your attendance. That is like the video. All right, we'll see you in another video. Thank you. Any queries, anything, you can let me know, or else. Okay, I think we are done. Thank you.